rules for computing event probabilities. Okay, so look, you know, in my previous lectures, so what is the probability? And now, in this lecture, I try to clarify some concepts, some rules for computing event probabilities. Now, the first question arises: what is an event? What is an event? An event, you know, is a subset of sample space. An event is a subset of sample space. Okay. And what is the probability? The probability of an event is equal to the sum of probabilities of the experimental outcomes in the event. So, if you consider the term probability of an event, it is equal to the sum of probabilities of the experimental outcomes in the event. Suppose you are flipping a coin. A coin, you know, your coin has two sides. On one side there is head, and another side there is a tail. So if you flip the coin, then you may find head or tail. If you flip one time a coin, then you can have head or tail. So probability of getting one head is 0.5, and or 1/2 or half, you can say. And probability of getting tail is the same, that is 0.5 or 1/2 or half, because you are flipping the coin one time. So here the outcomes, experimental outcomes, are 1/2 for getting head and 1/2 for getting tail. And if you sum up these two probabilities, that is 1/2 plus 1/2 is called the 1, is 1. So here the event is the flipping of a coin. Flipping of the coin. This is the event. Okay. And experimental outcomes are the you are getting head, you are getting tail, or you are getting tail. So in this way, the probability of an event is equal to the sum of the probabilities of the experimental outcomes in the event. Okay. Now, look, this is the sample space. You know, the blue shaded area is the sample space. Okay. And even this area, this white circle, is the event A. Okay, is the event A. So event is a, as I have mentioned, that event is a subset of sample space. Clear? Now, what is the remaining part? the remaining part that is out of this white circle within the sample space is the event AC, that is the complementary of event A. The C represents the complementary, that is complementary of event A. Now, if you consider the probability of event A plus probability of complementary of event A, then it would be equal to 1. Okay, it would be equal to 1. So this is the complement of event A. This is the complement of event A. Now, look, union of events A and B. This circle is event A and this circle is event B. Okay. So, event A and event B, and we are going to find out the union of events A and events B. So union means this part plus this part okay. So you can say if the two events A and B are there, the union of A and B is the event containing all experimental outcomes belonging to A or B or both. Yes. And the union is denoted by this symbol, A union B. Okay. A union B. So what I have mentioned? I have mentioned that if there are two events, event A and event B, then union of A and B is the event containing all experimental outcomes belonging to A, this event, or this event, or in both, okay, this part, or in both. This is the union. This is the union of, this is the union of A. Okay, so this is the, the union of events A and B. Yeah. Now the intersection of events A and B. Intersection of events A and B. Look at this very carefully. When there are two events in the same way, event A and event B, the intersection of A and B is the event containing the experimental outcomes belonging to both A and B. Just focus on this word. Containing the experimental outcomes that belong to both A and B. And you know the intersection is denoted by A, this is the intersection symbol, B. A intersection B. So if you see this diagram, then you can find the intersection of events A and B is just this area. Look at my cursor. This area is indicated by the intersection of events A and B. Now the mutually exclusive events. Okay, now the mutually exclusive events. And what is the mutually exclusive event? Two or more events are said to be mutually exclusive if the events do not have any experimental outcomes in common. If the events, that is event A and event B, do not have any experimental outcomes in common. So if you see this diagram, then you can find that event A is separate from event B. There is no common outcomes, experimental outcomes. There is no common experimental outcomes. Okay, so this is the mutually exclusive events. Now the addition rule. The addition rule. Very careful. This is the addition rule. Okay. This is the addition rule. The addition rule is used to compute the probability of the union of two events. And probability of union A and B equal to probability of A plus probability of B minus probability of the intersection between A and B. Then you have the probability of A union B. Clear? A union B. Okay. So now, if you see this part, look at this. If you consider this, it is A, probability of A. If you are considering the union of A and B, the probability of union A and B, then you should add the probability of A, event A, probability of event B minus this intersection part. Probability of this intersection part between event A and event B. Then you get the probability of A union B. Okay. So this is the rule. Now here is the problem. Now here is the problem, and you should focus this problem, very important problem. A study involving the television viewing habits of married couples, and it is found that 30% of the husbands and 20% of the wives were regular viewers of a particular Friday evening program. Okay, it is found. So, what information is given there? The information is that 30% of the husband study found that the 30% of the husbands and 20% of the wives were regular viewers of a particular Friday evening program. Clear? Both husband and wife were regular viewers in 12% of the household. And there is also another information that both husband and wife were regular viewers in 12% of the households. So now the question is, what is the probability that at least one of the spouses is a regular viewer of the program? At least one of the spouses is a regular viewer of the program. Now this problem can be solved by the addition that I have mentioned in my previous slide. Look, addition. Probability of union A and B. Okay. So probability of A union B, what does it mean? It actually means we are going to find out at least one of the spouses is a regular viewer of the program. Probability that at least one of the spouses is a regular viewer of the program. If such type of inquiries are there, then you have to use this rule, addition rule. Okay. Now the solution. What is the solution? So here H represents the husband and W represents the wife. And husband is a regular viewer and wife is a regular viewer. So naturally it is an event H and it is an event W. Okay. So probability of the event H is 30 by 100 equal to 0.30. Okay. And probability of the event W, that is the wife is a regular viewer, it is 20 because 20%, 20 by 100 equal to 0.20. This is the probability. Now, the intersection between the two, that is, the both husband and wife were regular viewers in 12% of the households. So this is the intersection part. So probability of A and the probability of the intersection of events A and B is 0.12. Now, as you know the formula, that is the probability of A union B is nothing but that probability of A plus probability of B minus probability of A intersection B, then just putting this value 0.30, 0.20 and 0.12. Okay, and simple calculation, you have 0.38. Okay, 0.38. So what does it show? There is a 0.38 probability. Okay, what does this probability show? There is a 0.38 probability that at least one of the spouses is a regular viewer of the program. At least one of the spouses is a regular viewer of the program. Okay, so this is the problem, and in this lecture, I have tried to cover mainly the rules for computing event probabilities, and here we have discussed the complement of an event. What is an event? You have the information from this lecture, and what is the probability, and also the complement of an event, and you have the union and intersection of events. Okay, with a diagrammatic representation, and there is the addition rule, and with a problem, and also we have focused on the mutually exclusive events, and at the end we have focused on a problem, so that the concepts of the addition rule is clarified. So thank you for enjoying this lecture.